Hello, today we're going to talk about the Pythagorean Theorem. Now, the first thing we need to recognize is that Pythagorean Theorem is based on right triangles. So I'm going to put the square in the corner, and that tells me that this is a right triangle, which means this angle is 90 degrees. So what we want to understand is how these sides relate to one another. Now, I told you that this is a right angle, and when we have right angles, that's when we can use the Pythagorean Theorem. Now, I already marked off units here. So this one has, this bottom piece has, the base has 1, 2, 3, 4 units. I'm going to write that here. This hypotenuse, which is the side opposite the right angle, has 1, 2, 3, 4, 5 units. And this height has 1, 2, 3 units. Now, the formula tells us that a squared plus b squared is equal to c squared. Well, I want to prove that. So what we're going to have to do is make some squares. So let's start out with this base. I have 4 units across, so I'm going to make a square out of that. Make my lines. So now I have 4 units across, and I have 4 units down. So that gives me a total of 16 square units. So I'm going to write over here 16 square units. Now our height has 3 units. So I'm going to extend this and make a square out of it. And that will give me a 3 by 3 square. And if this is, we're looking at a number of units, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we have 9 units. That's our height. And then here we have 5 units. And we're talking about squaring, so that's why we're actually making these squares, because we're squaring these variables. So here we're going to have, I'm going to have to erase this a little bit. And we're going to draw our square here that is 5 units across and 5 units high. That should be a square, but forgive my drawings. So now I have a 5 by 5 square, and 5 times 5 is 25. So we have 16 square units plus 9 square units, and that equals 25 square units. So our base of 4 squared is 16. Our height of 3 squared is 9. And our hypotenuse, which is the side opposite the right angle, is 5 by 5, which gives us 25. When we add the base and the height, or a and b, a squared plus b squared equals c squared, we end up with a correct solution, because 16 plus 9 equals 25, and 25 equals 25. We can do these square units on any right triangle in order to find out what the hypotenuse is, or whatever missing piece we have. So in this case, we were trying to figure out what the length of each side was. So we found that the base was 4, the height was 3, and the hypotenuse was 5. So 3 squared plus 4 squared equals 5 squared. Now let's look at this other triangle. Again, I'm going to tell you that this is a right triangle. We have to have a right triangle in order to use the Pythagorean theorem. So we're going to look at our formula, a squared plus b squared equals c squared. We could create our squares off each side to figure out what this hypotenuse is, but that's going to take us a lot of time, because we've got 12 squared, which would be 144 little squares, and we've got 5 squares is 25. It's going to give us a really huge square out here. So let's use the mathematical version of the equation in order to solve for this one. So A and B are going to be our legs. C is always going to be our hypotenuse, which is the side opposite the right angle. So let's start with our legs that we know. So I'm going to call this one A. So in place of the A, I'm going to write a 5, and I'm going to square that. My other leg is 12. That's going to be my B, and I'm going to square that, and that's equal to C squared, which we do not know. So let's go ahead and solve. 5 squared is 5 times 5, which is 25. 12 squared is 12 times 12, which is 144. And that equals C squared. Well, I'm going to do 144 plus 25. That gives me 9, 6, and 1. So 169 equals C squared. Now, we don't want to know what C squared is. We want to know what C is, which is the length of this hypotenuse. So we're going to have to take the square root of both sides. And the square root of 169 is plus or minus 13, which is equal to C. Remember that our radical and our square will cancel out. Now, here we've got a positive and a negative 13. Remember, whenever we take the square root of a perfect square, it's always going to have a positive and a negative, or even non-perfect squares. But we have to think about, does it make sense? Does it make sense to have a positive 13 for a distance or a length? Yes, that makes sense. Can we have a distance or a length of negative 13? Can we walk negative 13 miles? I'm not counting going backwards because that doesn't make sense. But we can't have a distance of negative 13. So I'm going to erase this because that does not make sense. So it's not going to be part of our solution. So in this case, C is equal to 13. So this side of the triangle, which is our hypotenuse, is equal to 13. Now we're going to look at the converse of the Pythagorean theorem. And that simply says, if the square of the length of the longest side of a triangle, the longest side, is equal to the sum of the squares of the other two sides, so the square of this plus the square of this, then the triangle is a right triangle. So this is a way that we can actually prove that a triangle is a right triangle if we're not told. If we have all 3 lengths of that triangle. So it says, let's go back to this. It says, if the square of the length of the longest side, what's the square of 10? Well, that's 10 squared, which is 100, is equal to the sum of the squares of the other 2 sides. So we're talking sum, so we're going to add these 2 numbers together after we square them. So what's 6 squared? That's 36. We're talking about a sum, and 8 squared is 64. 100 is equal to 36 plus 64 is 100. And 100 is equal to 100, which proves that this is a right triangle. So let's go ahead and walk through a regular Pythagorean theorem problem. So in this case, we've got a formula, a squared plus b squared equals c squared, or we could say the sum of the squares of the 2 legs is equal to the square of the longest side, or the hypotenuse. Remember, the hypotenuse is the side opposite the right angle. When you're describing the hypotenuse, please don't say it's the longest side. It technically is, but it has to be the side opposite a right angle. So we're going to do the sum of the squares of our 2 legs. Here are our 2 legs. Remember, the 2 legs are going to touch that right angle. So we have 5 squared plus 6 squared is equal to c squared. So let's think about this. What's 5 squared? Remember, this is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. And we know this is equal to c squared. 25 plus 36 is 61. So 61 is equal to c squared. Now I don't want to know what c squared is. I need to know what c is, what the length of this hypotenuse is. So in order to find that, we're going to have to take the square root of c squared. And if I do it to the right side, I also have to do it to the left side. Remember that our root and our square are going to cancel out. So we're left with c equals the square root of 61. We cannot simplify that any further down. 61 is a prime number. And if we wanted to, we could put that in decimal form. We just put the square root of 61 into our calculator and it would give us a decimal version. In this case, we're just going to leave it with the square root of 61. We're going to try another setup on this particular problem. We still have our Pythagorean Theorem formula, which we're going to use for this problem. A squared plus b squared equals c squared. But in this case, we're given different pieces of information than on the previous problem. So we have a leg. Remember, a leg touches the right angle. We have a hypotenuse. Remember, the hypotenuse is the side opposite the right angle. So in this case, we're given A and we're given C, but we do not know what B is. This leg is what we're missing. So we're going to write A squared. I'm going to say A is 4, so 4 squared plus, I do not know what this leg is, so I'm going to just write B squared equals, and our hypotenuse is 8, so I'm going to write 8 squared. We're still doing the same process in order to solve for this, but we want to make sure that we can solve for that B, and we just have to do a slightly different way to solve this. So we're going to go ahead and square the numbers we know. So 4 squared is 4 times 4, which is 16. Oops. And that is plus b squared equals, and 8 squared is 8 times 8, which is 64. Now we need to know what b is. And whenever we're solving 1- and 2-step multi-step equations, we remember that we need to isolate the variable. And in this case, b is our variable because we do not know what the value of b is. So we're going to have to get b squared by itself. So to do that, we're going to have to subtract our 16 from both sides of the equation. 16 minus 16 is going to cancel out. We're left with b squared equals, and 64 minus 16, if we do borrow 1 from here, make that a 14. 14 minus 6 is 8. 5 minus 1 is 4. So b squared is equal to 48. And what do you think our next step is? We've got b squared equals 48. We need to know what b is, not b squared, but just b. So in order to do that, we're going to have to take the square root of that, b squared, and if we do it to the left side, we must do the same thing to the right. So the square root cancels with the square, so we're left with b equals, and the square root of 48, it will simplify. We can, if we're doing the square root of 48, we can do 4 times 12, and 12 is 4 times 3. That gives us 2 4s. So that gives us 4 root 3. So b is equal to 4 root 3. We could also solve that in our calculator as a decimal, but in this case, I wanted to just go ahead and leave it as a radical. Now we're going to use that converse of the Pythagorean theorem. We're given a triangle, and we're given all 4 sides of that triangle. We do not know if it is a right angle at this point. So we're going to use the Pythagorean theorem to solve to determine if this is a right triangle. So we're going to identify what we know. If this was a right triangle, I see that this is the longest side, so that has got to be opposite my right angle. So, and that's the definition of a hypotenuse, is the side opposite the right angle, so that's got to be my C. My legs are 5 and 8, so those will be my A and my B. So let's start with 5 and plug that in for A. So we have 5 squared, and we're talking about a sum. So now we're going to do the other leg for B, plus 8 squared equals C is 12, and we're going to square that as well. So we have the sum of the squares of our legs equal to the square of the longest side, which would be the hypotenuse if this truly is a right triangle. So let's go ahead and simplify here. 5 squared is 5 times 5, which is 25. We'll add that to 8 squared, and 8 squared is 8 times 8, which is 64. And that would be equal to 12 squared, which is 12 times 12, and 12 times 12 is a gross, which is 144. So we have to find the sum of these two numbers. So let's do 64 plus 25. That gives us 9 and 8. So we get 89 equals 144. Because these two numbers are not equal to one another, this is not going to be a right angle. So I've got to erase this because it is not a right angle.